on the Zoom? Check, check. Can you hear me on Zoom? Anyone want to type in chat? Okay, cool. Thanks. Thank you. Hi, everyone. Welcome. I hope to at least meet those of you that are in person here, chat afterwards. Also hope to chat with the rest of you online as we're able. Thanks for joining. The purpose of this meeting is to one, maybe answer some questions if they come up on the Data4Good competition. But I think the main piece is to really try to give you some tools in your toolkit when it comes to AI engineering and prompt engineering, when we're talking about large language models and how to do a task like data extraction with large language models. So that's what I'm going to go through today. Let me share the screen here on Zoom. And I will try to monitor also for chat questions here. So if you have questions as they come up, go ahead and pop them in the Zoom chat. In person, maybe just like wave your hand or yell at me, and I'll pause. What I'm going to be going through is actually not all of this, but at least a portion of the material that I taught a few times this year at different workshops, either for industry partners or at conferences like QCon and ODSC. You can find this if you go to GitHub and you just look at Whitenack, that's my user, AI engineering workshop. This is a public repository, so you should be able to access this from any location or network. So just go here, and everything that I'm going to talk about is linked here, including if you scroll down, there's some slides. There's actually very minimal slides here. Most of the time that we're going to spend together is in code. But there are some slides here. If you click this link, there's some publicly available slides if Zoom cooperates. There we go. Publicly available slides here. And that's where this is where I'm going to start, and then we'll move over into some Google Colab notebooks. So all you need to do to kind of follow along, or afterwards, if you want to follow along, if your laptop dies or something, you can run all of this code in Google Colab notebooks. You don't need any sort of special environment, which means you can run all of this from your browser. No need to install packages or that sort of thing locally or install certain things. All you'll need is the prediction guard token that's part of the Data4Good competition. In one of the notebooks later on, I think that I illustrate how to do like a Google search and parse the output of that with a large language model. But you don't have to, so that also requires a separate API key, but I don't think we'll even get there today, and it's less relevant for the Data4Good competition. So, but if you're following along, you might need that as well. So just by way of introduction, move this. So I'm Daniel Whitenack. I've founded a Prediction Guard this year, so the company that's hosting some of the models for the competition. In the past, I've built up a few different data teams at a few different startups and also an international NGO. We did a variety of work around the world, extending machine translation, speech recognition, these sorts of systems into languages that weren't supported yet. As I mentioned, now I'm running this company, Prediction Guard, which maybe you've been using the API, maybe you haven't, but we're going to be using it today. So you'll at least see that. Our main goal is setting up enterprise AI infrastructure for companies that allow them to overcome some of the barriers that they face when they use large language models, like, hey, is the output factual or not? What is the consistency of the output? How do I make it more consistent? How do I structure the output of models? How do I make sure that I can run open models that are privacy conserving and are not leaking my data to to outside closed parties. So that's what we specialize in. I also co-host a podcast if you're interested in that. We do have another member of our team, Sharon here. Wave your hand. Can't see him online, but he's here as well to answer questions also. All right, cool. So let's go ahead and get started. All right. So the first thing I want to do is just give you all some intuition for what we should be thinking about when we're working with these models. I find that a lot of people lack this intuition, and as such, they sort of expect the models to behave in a way that they aren't really made to behave. So I don't know how many of you were actually anything but a child at this point in history, but I started data science around 2012, that sort of thing. And back in 2012, the primary way that we interacted with models was by creating a training data set, choosing a model like a support vector machine or a gradient boosting machine or something like that, and then training that model specifically to solve a very unique problem. So let's say that we wanted to create a spam filter. I get a bunch of examples of spam emails and not spam emails. I label them manually or use crowd workers to label them. I then train my model to make a prediction for spam or not spam using naive Bayes or something like that. This works really well for a lot of problems. Actually, this still is a lot of what happens in industry as related to machine learning. But in particular for language and natural language processing specifically, around 2019, certain things started to change. So as of 2019 or so, what started to happen is a few things coalesced. One is kind of large infrastructure to train larger and larger models became available. And also people found out that, hey, if I train a general purpose model on sort of a meta task, like not the task that I'm actually interested in, I can apply that in a bunch of different scenarios. So let me give you an example. Let's say that I train a model to fill in missing words in a sentence. So I just strip out a word, and I train the model to put in that word. As it turns out, if you do that on a large enough data set of language, then you can actually rapidly adapt that model for a variety of downstream tasks like text classification or sentiment analysis or named entity recognition or even machine translation, things like this. This is what's called, what people started calling base or foundation models, parent models that you fine tune for a downstream task. So you might remember this is around the time that Google released BERT, and that model kind of kicked off this wave of all of these different foundation models that we use now. But it still required you to kind of take this model that Google trained. So they did all the hard work. They trained the thing on 300 GPUs or whatever, right? They did all the hard work, but I still have a small amount of data that represents the problem that I'm interested in, like named entity recognition or something like that. And now I'm gonna adapt that model or fine tune it or just slightly modify the weights of that model to accomplish my downstream task. That then led us up all the way to today. So today, things are almost entirely different from when I started doing natural language processing back in 2012. Now, what people found is they kept training these larger and larger models on these meta tasks like take a word out, put a word in, or autocomplete. And they kept training them on more and more data and eventually trained them on like the internet's worth of data and found that, hey, the internet represents a lot of tasks that I want to do fairly frequently. Like it includes blog posts or documentation about code or instructions how to cook like a fried chicken dinner or something like that, right? So I can actually now prompt that model, which is just trained to autocomplete language, and it's seen so much language that now it seems like it can just fulfill my request, right? So I can say, for example, a great way to make a fried chicken dinner is, and then I get this great recipe for a fried chicken dinner. It tells me how to do it, right? The reason for that is not because the model knows my intent and that I want like this particular type of recipe. It's just seen so many examples of this that it's able to autocomplete that with very, very high probability. And so this caused people to say, okay, well, now this kind of changes things. What if we train these large models specifically geared towards this sort of instruction following or chat completion sort of task? Then these are general purpose models, and my job as a user of this model is no longer to bring my data to the table necessarily, but for me to figure out an appropriate prompt to prompt this model to get it to do what I want it to do or output what I want it to output. What's interesting is now the only thing I'm bringing to the table is this prompt, and the quality of the output of my model is only dependent on this prompt. That's the part under my control, right? Everything else is completely pre-trained. Okay, so I said a lot of things there. Let me just pause to see if what questions there are. Looks like there's maybe a chat here. Okay, yeah, thank you. Yeah, thank you for doing that. So a couple notes on the key. I'll make a couple notes on the deployment of Prediction Guard that we're doing in case there's some issues that people are having with that here in a bit when we dive in. Any questions about this sort of generative AI specifically and how to think about it? There's got to be at least one question. Either that or I'm so boring, or it's Friday night and you're like, I really just want to get to Harry's. Please let this be over. No questions at all. This is amazing. I could also just sit here in awkwardness. I'm really good at awkwardness until someone asks a question.
I do have a question.
Yeah.
Yes. So when it comes to prompt engineering, so are we here with generative AI? Are we trying to basically train our or the large language models with our prompts, or because I feel like I don't really get it.
Yeah, thank you for the question. So hopefully as you see some examples, some of this intuition will sink in. But to answer your question, when we're prompting this model, we're not retraining it at all. So we're actually just giving it strategic input. The model itself is completely static. Nothing changes about that model. It's just this prompt that we're giving it. It's just that it seems like if you do certain types of prompts, it behaves in a certain way because it's very highly dependent on the prompt input, meaning small changes in this prompt might produce very wild fluctuations in the output because that's the only thing that's under our control here. But we're not retraining the model. It's just that we're strategically formatting the input for a task. Hopefully that helps.
Makes sense. Yeah, thank you.
Yeah. Other questions? Yeah. Yeah, so the question was in the audience was that models that are trained on a certain amount of data are naturally limited in time because, so for example, the original GPT models that were in ChatGPT were limited to 2021. I think they've updated it now to 2022 or something like that. So if you're just prompting a model, you might get facts from like 2021 that aren't relevant anymore. That doesn't necessarily mean that if you want things relevant to today that you have to retrain the model, but it does mean you have to be very strategic about what you put in your prompt. So for example, in your prompt, you could inject information about the current moment and have the model reason over that data that you inject at the time of prompting. So this is called in-context learning. And I'll talk a lot about that as we move on. Yeah, good question. Okay. Let's keep going. Just very briefly, so you all know, in terms of the models that you can use, there's a whole variety of these. You're probably familiar with like OpenAI, Anthropic, Cohere. These are closed and proprietary models, meaning you will never be able to download this model. You can't access the weights. All you can do is connect to a product, send your data to an API, and get the result. Okay, that's how these models work. They are generally very high quality because they're products. They're not models that you're just getting the raw output of. They're actual products, right? The downside is some people are hesitant to send their data to these companies, especially if it's private data and it can't leave their network or other things like that. Like in our case with the healthcare use case, that's why we've emphasized some of these open models or private model endpoints, because specifically in healthcare, that's a concern with where you put your data, right? There's open and restricted models, which means you can totally download this model, but use your caution because technically you could get sued if you use it in a commercial context. So these are models that are released openly, but it's just like on GitHub. GitHub has code that has all sorts of licenses associated with it. Some companies can't use everything on GitHub because of the license that's associated with it. These are like Llama, the original Llama, Stability, XTTS. And then there's open permissively licensed models, which are basically, yes, I can download this and I can use it for mostly whatever I want. Now, each of those has different sorts of licenses, but for the most part, these would be permissive like Llama 2 and Mistral. I want to go through some of these things in this workshop, but specifically, if you take away nothing else from this workshop, this is what you should take away from it. So this I greedily stole from Travis Fisher and kind of adapted it for my own purposes. But when you're approaching a problem in generative AI or a large language model problem, you're trying to develop a large language model solution, there's a variety of ways that you can solve that problem. These variety of ways range from very simple to implement and try to very, very complicated and hard and extremely difficult, okay? So that's what I mean by simple to easy, simple or easy to complicated and difficult. You should always, whether it's this problem for the Data4Good case or another problem that you face in your career at some point, you should every single time think about starting at the top, convincing yourself that that rung of the ladder doesn't work for your solution, and then dropping down to the next one, okay? So it's very, very simple to connect to a large language model and try a very simple prompt. That's what I mean by basic prompting. It's on the complete other spectrum to say our company is going to train our own LLM from scratch on 400 GPUs, right? There's a whole world of difference between there, right? And you should never leap to, actually, I think probably there's very few groups or teams on the planet that should ever drop down to that last tier of training your own large language model from scratch. But we're gonna focus on these things. It's possible that maybe at some point you might need to fine tune one of these large language models. Almost all of our clients are getting their jobs done without fine tuning any model. They're either using basic prompting techniques or they're combining their own data or augmenting their prompts with retrieval, like we'll talk about here in a bit. But sometimes you may have a very unique scenario where you need fine tuning. So this is what we're going to go through. We're basically going to start at the top and see how far we get all the way down. Questions as we jump into that? Comments? Snide remarks? Nothing? Okay. This is not relevant because we're not at a conference. Okay. Just an aside on LLMs. So here, let me just stop sharing and switch something over here. Hold on just a second. See if this works. I think this only changes. Just need to switch something, sorry. Okay. Any questions while I'm fooling around with various screens? Nothing. Okay. All right. So as we jump into this, just a mental model that you should have in mind is the following. So I wanted you to have, yeah. Oh, okay. I've stopped sharing. Okay. Thanks. There we go. Okay. So instead of my definition, I wanted a succinct definition for you all to have in mind as you're working with these models. So I had a large language model generate one. So that this is a generated definition, but it has some good features. So just remember, as we work with these models, they have learned from a large corpus of human written text. As mentioned, they have sort of time gaps and potentially knowledge gaps. They are autocomplete models. So don't let anyone tell you that ChatGPT understands you. It's an autocomplete model, right? It knows, it predicts like what next word should come next. It does that very well, and so it seems coherent, and so it's natural for us as humans to assign an intent to that entity, but it's just an autocomplete model, which means that it predicts likely next text, likely text in a sequence. That likely next text is completely determined by the preceding words or a prompt. And the model then selects likely words to generate as the next word in a sequence. Okay, so here these models are trained to predict probable next words. They don't have any understanding of user intent, but we can think of them as tools that occasionally hallucinate. But with some of these techniques that I'm going to show you, we can do pretty great things. You can kind of think about this like, hey, is it useful for me to assign you a high school intern to accomplish some tasks? Yeah, it's probably useful. Can they do everything you ask them to do? No. Will they make mistakes? Yes. Does that not make them useful? No. Especially if such a high school intern can work 24/7, and you can have as many of them as you want, thousands of them, right? Can you get a lot done in that case? Yes. But you need to have a proper kind of understanding of what the limitations are. Okay, so let's talk specifically now. Let's get into some code. If I can, I move this? Zoom? There we go. Move this down here. All right. So if you're on this GitHub repo, you'll see that there are, oh, chat, maybe a question. Kavya asks, what kinds of outputs or results are you expecting from the model? Are there specific formats or structures that I should adhere to? Yes, Kavya, there's definitely specific formats or structures. And we'll talk about a few of those as we go along. In terms of what you're expecting out, you're expecting a probable auto-completion that comes after the prompt that you put in. So that's always what you should be expecting out of the model. Okay, I think that's the last question. Oh, Sabrito asks, stable Beluga. Stability posted a license for stable Beluga that prevented us using it, so we took it off of our API. So you can't use it commercially. So you can use it if you want, as long as you're not using it commercially. If there's no answer to the question in the given, okay, so, I'm gonna pause on this one, Hardik. I think this is in relation to the case specifically. I'll return at the end to some of the common questions that we've seen in the case competition, but I wanna make sure that I get through some of the workshop things. Okay, let me close that. All right, so if you're on the GitHub here, there's a bunch of, if you look at these IPYNB files, these are Jupyter Notebook files. If that means nothing to you, that's totally fine. Jupyter Notebooks are just a way to run code interactively in a web application. Thankfully, Google has hosted a version of this for us. So if you search for Google Colab, and then you just go to that first link, it'll bring up this page. But also conveniently, you can open a new notebook. Maybe I'll have to sign in as myself here. Let me see. New notebook. Okay. Give me a second to sign in on this computer. Stop sharing. Sorry. On Zoom? What's that? Okay, I think we're good, right? Okay. Trying my best not to share all my passwords. It's not that I don't trust you guys, I swear. Okay. Cool. Okay. Okay, we're back. Okay. All right, so if you're in Google Colab and you're logged into your Google account, what you can do is just go here to this file, open notebook. And if you go to this GitHub tab, you can type in this link from GitHub. So if you go to that link that I shared, that GitHub workshop, and search for that, that's going to bring up all of these notebooks. And the first one we're going to look at is this Access LLMs. If you want, you can read a little bit. I already said most of this. We're going to access these LLMs, specifically the open permissive ones, through the Prediction Guard client. Let me zoom in as well. Probably better for people here. Is that okay for you guys in the back? Yeah, okay, cool. So first off, we're going to use, so this is all Python code that we're executing in these cells. If you've never used one of these notebooks before, you can either go into one of these cells and click Shift-Enter. Say that you trust me, click Shift-Enter, and you can run it, or you can click this little play button to run the code. So this is going to download our client to connect to the models that we've deployed for you guys. And then we're going to import a couple things here. You'll need to put in that authentication token, or the access token for Prediction Guard. And then you should be able to then interact with the, oops, I think I copied something else when I copied the, here, let me re-enter this. Sorry, guys. Okay. Stop sharing and get that token. Any questions while I'm grabbing my token? Yes, I think that, oh, actually, you know what? I think that it was shared in here. Okay. It's in the pitch post, and it's in the Zoom chat. So, on the Zoom chat. Oh, okay. There we go. All right. Okay. All right. So you can see a list of models here that are supported. Now, the first thing we're going to do is just see how we access one of these models. So the simplest way is just to run this completion create command. So pg.completion.create, the model llama 2, and let's see the best joke that the llama 2 model knows. Oh, I'm sorry. Thank you. Okay, that's better. Sure. Okay, so here I was just sharing, so this list models will list models available in the client, and then we can run this completion.create command, just providing a model name and a prompt. So remember, these models are an autocomplete model, so the best joke I know is something. And here in the output of this function or this method, after it calls the large language model that we're hosting, is a JSON formatted response. Here I've just outputted that full response. The main piece of this that you should be interested in is this text. So this text is the completion of this prompt. Remember, these models are autocomplete models. So the best joke I know is, and then Llama 2 says, why don't scientists trust atoms? Because they make everything up. Now, notice a couple of things about this. What do you notice about this completion that's sort of interesting? Anyone? Yeah, let me output. I'll just print it out so people can see it here too. What did I call it? Response. Okay, so here you can kind of see it. Was mentioned that there was numbering. What else do you notice? What's that? Yeah, it has new lines, and then after the new line, it just sort of like keeps blabbing on, right? It's like, hey, the joke is a classic. It could be used in many situations, blah, 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 and it tells me how great the joke is. So for one, it never makes a joke funny to explain it. But also, in this case, I just asked for a joke, and it just kept generating text. So remember, here, these models are just going to generate text. There was no perception of the model that knew that I wanted it to stop after it generated the joke, right? I'm going to skip this piece because we're not using OpenAI here. Yeah, Aaron, I'll share the token here again. Okay. Okay. So that's just the sort of general API that you can use to access these models. Let's go on then to the next one. So you can again go to this AI engineering workshop, and we're just going to talk a little bit about basic prompting techniques. So again, we're going to run this notebook, install the client. This will need to be done wherever you're running these things. And then we're going to input our token. Hopefully I have the right one copied this time. And the first type of prompt, so remember here in our hierarchy, what we want to do is think about going from basic prompting all the way down to training a model from scratch. And the first things we need to try are basic prompting and prompt engineering. We'll talk about engineering here in a second, but let's just try some basic prompting. If we suspect that these models are autocomplete models, the most basic thing we could do is ask them to autocomplete some things. So we could say, hey, Llama 2, 13 billion, here's a story about Daniel Whitenack, a long forgotten wizard from the Lord of the Rings. He entered into Mordor to do something, right? Apparently I entered to fight the evil Sauron. Oh, dang, I was captured and imprisoned. That sucks. Now that's a kind of a silly example. You could see maybe how that would be useful. I don't know, in like a word processor or something. Maybe you're doing autocomplete there. Maybe something a little bit more profound for like a industry use case might be, today I inspected the engine mounting equipment. I found a problem in one of the brackets. So I did something, I adjusted it accordingly, and the engine was still not level. So I decided to blah, blah, blah. So you could have reasonably technicians that work in your company that have to create reports, and maybe you're auto-completing some things for them as they create those reports. It's not necessarily, though, even restricted to natural text output. I could also, because these models have seen a lot of structured information and code, I could ask them to complete things like this, like a SQL query for me, right? So here I give an initial SQL query, and then I ask it to complete it. So it wants to select count from LLM queries where name is autocomplete. So all of these prompts have no, as was mentioned in one of the comments earlier, these have no structure. They have no sort of engineering behind them. They're just, I'm just hoping that I get what should come out of that, that autocomplete. Any questions about that? Yeah, so the question was, is there, should we or could we take the output of one prompt into the input of another prompt? So yes, definitely, that's highly recommended. That's what's called chaining. So I'll talk about that in a coming notebook if we can get there. But the basic idea is that the more complicated of a task you want to perform, the harder it is to describe in a single prompt instruction. And generally, models, even like the most powerful models, will fail on a more complicated instruction. So the better thing that you can do is split out your prompt and decompose your problem into multiple prompts. So let's say I want to, you know, generate a tweet about Purdue University, and then add some emojis, and then translate it into German, and then, you know, write a SQL query that saves it to my database, right? If you put all of that in an instruction to a single instruction to a large language model, it's highly likely that that's going to perform much worse than if you split up each of those discrete tasks and make individual calls. Not only that, but if something goes wrong, it's very hard to sort of debug and improve the single prompt scenario. It's much easier to improve individual targeted prompts in a chain. Yeah. Other questions before we move on? Okay. Zero shot or instruction prompts. So the question earlier was, do I need to follow any specific format or structure as I'm prompting large language models? You might be used to going to ChatGPT and just like pumping in some text and you get some cool output. Remember though that ChatGPT or these closed models are products in and of themselves, and they're structuring what you put into them under the hood into very specific formats that they can manage internally. As soon as we're decoupling from some closed product and we're using a model directly, it's on us to make sure that we're structuring a model prompt in a sane way. What I would recommend is thinking about your prompt in this following format, in a threefold format. Now, this would be true for any sort of instruction-based model. There's other formats for chat or dialogue models. For this competition, for the Data4Good competition, the chat element isn't quite as relevant as the instruction prompt. So that's what I'm focusing on here. In an instruction prompt like, hey, give me the name of the patient, blah, 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 the best way that you can structure this prompt is by adding 3 sections. First, a task description or an actual instruction for what you want the model to do. Then a middle section that's the current input or context. And then a last section that's what's called an output indicator. What this means is you're telling the model, I want you to do this using this data, now do this, right? So it's that sort of structure. This middle piece, why I label this as current input or context, is this is what's going to change each time you use this prompt, whereas the other things are pretty much boilerplate. So if you have a prompt that says, what's the patient's name in this transcript, and then you have an output indicator, those things are aren't going to change for whatever transcript you're parsing. But what is going to change is the transcript, which you're going to have to inject in the middle of that prompt. So here, let me give you an example. Here's an example sentiment analysis scenario. So if you notice, I have these 3 sections. So an instruction, current input, and a response. Now, here, let me just run this. and I get out a cool sentiment label. Now, like, just to emphasize here, like, when I started doing data science, I had to use a sentiment model, a specific sentiment model to get sentiment. Now I just type in an instruction and I get the sentiment, right? Which is pretty cool to note. But one thing that you'll also see here is a very specific set of what looks like almost like markdown formatting. Why I did this is very specific. It follows this 3-section format, but also remember how I said that the creators of these larger models started realizing that people wanted to use them for instruction prompting, right? So they started training them specifically for instruction prompting using an instruction prompted format. What this means is that you can put any format you want into this model. It doesn't care. It's going to process whatever text you put into it. But if you align the format of your prompt to what the people that train the model on, you're going to get better performing output. And specifically, if we look at the this fine tune of Llama 2 from Noise Research, you just search for that, you'll find the model card for that model. And if you scroll down, you'll see, hey, here's a prompt format. They're literally telling you, we fine-tuned this model using this specific format of prompts. So you can put anything you want into this model, but you're going to get better performance if you follow one of these formats, which you can see is already in this kind of 3-structure form. And this is very specific. So they're not implying that you can have like hashtag, hashtag, hashtag anything. They literally always want you to have instruction, input, response, or instruction, response, and then you fill in the various sections. That's why I've specifically formatted this in this way. Are there questions about that? Okay. Here's the great news that I have for all of you. All of these creators of these models have not used all of the same formats. And so it's on you to figure out what format is to be used with what model. There's absolutely no standard. It's the complete Wild West. So the best thing that you can do is do a little bit of research on the model that you're using and see what data set of prompts they use to fine-tune that model or to preference train that model, and then try to adapt your prompts to that specific format. Some of them are different than others. Yes, so the token that we're using does have a rate limit. Unfortunately, I don't have $1 million to spin up 1 million GPUs for students across the nation. So somehow this has to be rate limited, or else I can't employ my staff. So there is a rate limit on it. I think it's probably, you may get rate limited more right now because everybody's online at the same moment using the same token. But yes, sorry about that. This was, other than having you host your own GPUs, this seemed like the best way to get you access to these models, at least on our side. Okay, other questions other than I want more GPUs? All right, cool. All right, let's look at another couple of prompts here that are in this sort of instruction formatting. Here's a question answering example. So you've got, again, instruction, input, response, exact same hashtag labels for all of these, right? And then I got the, here I'm saying read the context in the below input and respond to the question, or respond with an answer to the question. If the question can't be answered based on the context alone, than say, sorry, I can't answer the question. Now, what's interesting here was brought up earlier that these models only have so much sort of internal knowledge. They don't really have any internal knowledge. They just know probabilities of words. But the probabilities of the words that they know about are restricted in time. So here I'm asking, how are gift cards delivered? Now that's a very general question, right? I could say, how are gift cards delivered? That's not specific to a company. And even if I say, how are Domino's gift cards delivered? Well, I'm not, if I only provide that question, then I'm relying on some sort of training data that the model was trained on. Maybe gift cards are delivered differently now than they were in 2011 or 2021 or something like that. So what is best to do here is actually insert the context that you want the model to use to answer the question. Now, you could get this from a database or from the web or from wherever your data is coming from, but you're saying, read the context below and answer the question. Here's my context, here's my question. And then you're forcing then the model to use the context here to answer the question. So this might seem disconnected from healthcare transcripts, but it's actually very similar, right? So you could say, what is the patient's name, right? Well, absent any transcript in the prompt, it's just going to make up a name, right? Which is going to be wrong. So in the context of the prompt, you need to add in the relevant things from the transcript to get the LLM to answer the question based on something that's in reality. That's what we're doing here. Okay, in this part of the workshop is where I sort of went off the rails. I tried to think of something that maybe would be really hard to do in a prompt. And I said, hey, can we do fraud detection, 0 shot, without anything else but an LLM? So I said, hey, create a numerical fraud score for a customer of a life insurance company based on their transaction history. And then I gave a transaction history. So I think in this case, it will respond with a number, 70%. It's 70% likely that this customer is a fraudster based on their transaction history. Now, if we rerun this, right, it's probably going to give me something else. Now it's 0% likely that this person is a fraudster, right? What does this reveal about these models? What it reveals is that they're good at predicting text. They're usually bad at anything numerical. Moreover, there are limits to what you can get out of prompting these models, right? This is not a model that's likely seen transaction data like the transaction data that I'm putting in. Like there's a limit to what it has seen. And so that's why I'm getting more variable answers. Now, the other thing is like this model is not just going to tell you that, hey, sorry, I'm not very confident in giving you this answer. No, it's just going to straight up lie to you and tell you a number and say, this is a great fraud score, use it, right? So it's up to your own judgment to know that like, this is a scenario in which likely I don't want to be using this sort of technique. I try another couple of things down here if you wanna look at that. Before I go on to the few shot prompts, any questions? Yeah. Yeah, so let's just try it. So the question was, what if I do something like the following? So here I've got a reward amount column, right? Let's just say that I add in here something like I'm going to add in a statement that says output a score based on the average of the reward amount column. So I can try to be specific here. It's still going to give me an answer, and it's likely still going to be quite variable. Now, it may rein that in a little bit, right? Like, it's possible. The thing is that it isn't necessarily connected to any reality of the world that we live in, right? It may just think high reward values are, fraud, or low reward values are fraud, or something like that. So I think like you can certainly do things like that, but another thing to recognize here is I'm making this prompt quite complicated. As we said before, the more complicated of an instruction you're going to give, the more likely it is you need to decompose that prompt instruction into multiple different LLM prompts. So what I could do, if I think the reward column is like, is indicative of fraud or something, I could have a bunch of customers and have an individual LLM prompt for each customer that gets maybe the average or the maximum reward value. And then I could combine all of those into another prompt to see if the model could pick out the one that like doesn't fit or something like that. I have my suspicions that that wouldn't work either, because most of these models, again, are not very good with numbers. But you could try to decompose it in that way. Other questions? Yeah. Let's do it. So the question was, what would happen if we remove the do not respond with any text bit? So now I am unable to calculate a numerical fraud score as there are no information provided. So I've run this a bunch of times in different workshops. Sometimes if you do this, it will still give a score along with text. Okay, here it tried to give us some formula, which is kind of cool, actually. Maybe it's a nice formula, maybe it's not. But yeah, that's specifically why I added this in to see if I could get a score. So this is a very good, we were just talking about this the other day at work too. You know how in like the text to image models, you can say something that's a negative prompt, not just positive, like I want you to do this, but a negative prompt, meaning like create an image of an astronaut on the beach. Please do not include a whale, right? Like this is a negative thing that you don't want to be included in the output. You can do the same thing with text prompts in reducing the variability in the output. Okay, let's talk about few-shot prompts a little bit. Few-shot prompts are generally associated more with this sort of in-context learning feature of large language models or generative AI. What we just talked about was zero-shot prompts, meaning this model knows how to autocomplete things. I'm describing something I want it to do, and then asking it to do that thing without giving any other context or any other examples of how to do that thing, right? This is what we call zero shot. It's like, imagine that you hired that high school intern and you said, file this paper in the right location, right? It's very likely that that high school intern has no idea where to file that paper, right? Now, if he's done it a bunch of times, he or she, then probably they know where to put it, right? So the idea with a few-shot prompt is, let's not just give it an instruction, but let's give this model a few demonstrations of the type of task that we want to do. So this is called in-context learning because we are not training the model at all here. We're still just using the pre-trained model. We're not modifying the model at all. What we're doing is we're creating a prompt, something like this. So now for our sentiment example, instead of saying, hey, classify the sentiment of this statement, now I say, classify the sentiment of the following statements or of the text. And then I give examples. So I say, hey, here's text, here's the sentiment. Here's text, here's the sentiment. Here's text, here's the sentiment. And I give a whole bunch of examples of that until I say, here's text, sentiment, and then I let the model tell me what that sentiment is. So hopefully that sentiment is negative. Now, notice still, there's a unique artifact here, which is that the model picked up on the pattern that we were doing, right? It knows that we were giving text, sentiment, text, sentiment. So it said, oh, great, you want more text and sentiment pairs? Let me give you another one. And so it just completely made one up, right? So that's fine. We still got the right sentiment label, but this is an indication that you don't always want the direct output of a large language model. What you might want is a post-processed version of the output of the large language model. In this case, I would really just want the tag here, the negative tag represented. Here's a fun one. Here's transform text statements into first-order logic. This was one that I was working on with a friend of mine who's a computer scientist and really smart. I don't know anything about first-order logic, but apparently you can represent statements like with these cool symbols that somehow represent the logical relations between them. And so we tried this, and you can get the model to output this fun sort of representation of your text. I don't know if we have any English speakers in the audience. I suspect that we do. Here's an example of this in a chat context. So I say the following is a conversation with an AI assistant in English, which is translanguaging between English and Hindi. The assistant is helpful, creative, clever, very friendly, and the AI assistant responds in English. And so here's a conversation, I think, about some movies and actors. And let's see if we can get one of you can tell me what this says, something about American comedy films. Will Ferrell, Seth Rogen. And here, I can't read this, but it says something, hopefully something not offensive. But this is where me as a English speaker, I don't know what this says. It would be much better for me to output the statement and then chain another LLM call in to actually do the translation. So let's just do the translation of this back into English. I don't know if that's a good translation either, but there you go. So again, this doesn't mean these are great outputs, but at least they appear to have the same form. I don't know. Any English speakers, did it translate right? Okay, it translated okay. So this kind of draws together a few things. One is this few shot prompting, and the other is the chaining element that we talked about a second ago. So you can chain the output of one call into the input of another call to actually get more complicated behavior. What questions are there before we move on? Okay, so the last notebook that I want to share with you today to kind of level up some of what you're doing in the competition is the following. Is the prompt engineering one. Leave, okay. So here, I'm going to install another package, which is really useful. It's called LangChain. LangChain, you can search the documentation of. They have a ton of great stuff to help you. There's no way that I can get through all of it in this workshop. They have a huge amount of functionality. But we're going to use them for a few things. The first is, hey, remember how we had this zero-shot prompt? That's totally cool, except I don't want to be like manually copying and pasting context into prompts over and over again. Now, every programming language, whatever you're using, JavaScript, Rust, Go, whatever, is going to have a way for you to substitute strings in other strings. But LangChain specifically has developed a set of templates and template tooling that allows you to template out your prompts and insert things into your prompts very conveniently. So for a zero-shot prompt like this is how you would structure that. So if you're going to do this sort of question answering over and over and over again, what you can do is you can put these handlebars or braces around the variables that you're going to want to insert into your prompts. So context, question. And then now we have what's called a prompt template. And now whenever I want to call my prompt, all I have to do is put in the given context and the given question, and I can do that programmatically to generate the prompt that I had before, right? So this is just a very simple substitution. You could do this in any programming language very easy. But this gets more useful when I use it for few-shot examples. So here, these few-shot examples are generally more complicated. And if you remember, like with my sentiment one, it included a bunch of different pairs of inputs. And so I actually have a template for those pairs, and then I can define that template, and then I can use that template along with a list of examples to generate a few-shot prompt. And when you generate the template, you just have to provide the examples, the demonstration prompt, and then you can give a prefix to the prompt that gives the instruction, and then the output indicator, which in LangChain speak is called a suffix. And so here, now whenever I want to do sentiment, I don't have to copy and paste all of this around. I can just call this one line few-shot prompt.format, and then it'll format the prompt for me. Here I give another example of a text classification prompt. If you want to look, you can. The other things that I want to mention here are what are called parameters. So as you might have noticed, if you go into like the OpenAI playground, or if you go into some of these other playgrounds, you can not only modify the prompt that you're sending into an LLM, but you can modify certain parameters that change the behavior of the output. One of these is called temperature. One of these is called max tokens. Those are the most commonly used ones. Temperature is kind of interesting. Let me explain what happens. So let's take a model like Llama 2, which we're using a lot. That model has 30,000 different output tokens that it can generate. You can think about them as words or subwords or even characters. So every time you put in a prompt, what happens is in the inference code, the model determines what the next probable word is, and it does that by assigning a probability to every single one of those 30,000 tokens. And one of those 30,000 tokens has the highest probability, so it's the most probable next word. Now, what is interesting is if you always choose the next most probable word, your outputs are actually kind of boring and stupid. That's what people found out essentially. So I don't know if you remember, like a couple of years ago, there were a couple other applications before ChatGPT. There was one called Write with Transformer, and you could like autocomplete things. Those models, like they generated like okay text, but it wasn't really appealing in any sort of creative way to us humans. So what these creators of these latest generation of models found out was, let's not always choose the next most probable token. Let's actually modify the probability distribution of the output such that occasionally I choose the second most probable token, or the third most probable word, or the fourth most probable character, right? And if you introduce a little bit of variability into that, your outputs all of a sudden become more rich and appealing. The downside of that, which we'll see in a second, is they also become potentially more random and stupid as well, if that parameter is set too high, right? One thing to note is, you might think if I bring my temperature all the way down, which kind of removes this randomness element. So the temperature parameter usually goes from 0 to 1 or 0 to 2, depending on what platform you're using. If I bring it all the way down, then do I always get the same answer out? You would think you would. Sadly, that's not quite true. These models are never completely deterministic, at least in their implementation. Usually there's still some variability. There's just less variability for lower temperature values. So I'm going to illustrate this here. If I go temperature 1, and I ask this model for a great name for an unknown wizard other than Gandalf and Radagast from the Lord of the Rings, then I might. Oh, this model might not be spun up for you guys. Just a second. Okay. It's spinning up. So I'll just use a different one. Okay. So low temperature. Here, you can see that the answers are like almost the same. Actually, this first one and the third one are like almost the same. Looks like I got rate limited. Everybody's trying to run loops with their models, which is fine. So here, this one is very much the same. You can see even as I add a little bit more temperature, this all of a sudden becomes a little bit more crazy. I get a mention of Dumbledore. And if you were to run this over and over, I should probably add some sleep in here so I don't get rate limited. But you'll see more variability as you go along. The other thing that you can do is try modifying this max tokens. That one's pretty simple. That just modifies how much text is generated. So here, let me give a simple example. So here, I'll show this other prompt. This is a text classification prompt where I'm wanting an output class. I can modify this and say max tokens equals 500. Oops. Wrong. Oh, maybe we are getting rate limited now. But I think you get the point. The max tokens equals 500. I think there's probably a good number of people across the world running loops right now. So I probably did that to ourselves. Okay, so here, that was kind of the last parameter that I wanted to mention. The last things that I wanted to mention as we're kind of closing out here and going to question answer time are just a few things that you can try as well. There's nothing preventing you from providing sort of multiple formulations of prompts. So you can actually try one question answer prompt and another question answer prompt, and get both of those answers and then try to merge them together in a second prompt. That's what some people do. There's also ways that you can type check or validate the output. So here you can read about that a little bit more in our API documentation if you're interested. And then there's a way that you can also check the consistency of the output. I give some examples here. One thing that might be interesting for you all is in our API, you can also add a factuality check onto the outputs. So here there's a completion and then there's a fact score. If you're interested in checking factuality of outputs, that's supported in the API. But I think, I know we're running short on time and I want to have time for some question and answer, but hopefully this gives you at least a way to start out your prompting and have some tools in your tool belt to get started. A couple of notes on this, the hosting of these models. As you saw, if we have everybody hitting the model at the exact same time with the same key, literally, and I mean like literally at the same time, like we were just doing, I think the current API with this key is limited to like 50 requests per second or something like that. So that's what we're supporting for that key. What I would recommend is, number one, try to be courteous to people. So if you're doing things in a loop, maybe just add like just a brief like a couple milliseconds in there to like make sure there's room for people to use the system. Secondly, there's a variety of models that you can try in the API, and hopefully you can see kind of some of the different output. One thing I'll mention is we've provided this account for the students, and technically, you know, it's one account, and as such, you may see some issues. But if you're having any issues and you just literally can't get the thing to work or something like that, we're more than willing to help you and figure out what's going on. If you go to our docs, this docs.predictionguard.com, there's an invite link here for a Slack channel. And in that Slack channel, that's our team Slack channel, Prediction Guard Slack, where we're supporting other deployments of this platform. So please join there. And if you're having issues, you're getting frustrated or something like that, we've got all of our team members in that Slack. So we're more than willing to help you. We just, I think most people in the competition are in the US. We'll be in there sort of in US working hours. Although I guess some of you are students, so maybe you're working at like 1 a.m. or something. We won't be in that channel, sorry. Or I hope not, maybe Sharon will, I don't know. So please reach out. We'll do our best to, if we see that if we see that there is an unreasonable amount of frustration around some of this and people aren't able to run that, we'll try to scale up that rate limit and such without us losing like $10,000 a month or something. But we'll try our best to support you with as many GPUs and help as we can. But the best way you can do that is by reaching out here on this Slack channel. We'll try to monitor pitch in the other places, but sometimes we miss those messages. Matthew and others do a great job of forwarding those along. It's just sometimes we miss them. The other things I wanted to mention as we're wrapping up here, just some of the common things questions that we've already seen come through on the competition. So one is, you might have found a few Easter eggs in the transcripts that are not in English. So we know that those are in there. I think this was posted to the pitch platform as an answer, but in case you're wondering, we are expecting the answers to be in English, even if the transcript is not in English. So if a person is suffering from joint pain and they say that they're suffering from joint pain in Mandarin, we expect the answer to be joint pain, but in English. So we're expecting those answers to be in English. Another common question that we've seen come through is sometimes the transcripts aren't explicitly giving a certain answer, like an age or something like that. The transcripts are simulated based on someone's age and that sort of thing. In the case that in the age column, there's always going to be an expected age that I think either it's there in the transcript or you're supposed to guess it. For the other one, the medicine, I think it's prescription or medicine column, like isn't it medicine used or something like that. If the medicine is not, if there's no, obviously there's either a medication prescribed or not. And in that case, if there's none prescribed, you can just respond with none. I think that, I'll confirm that right after and post to pitch if I'm getting that wrong, but if I'm remembering right, that's how the data set is set up. Also, some of the things here like are real problems that people are facing in industry, which is it takes a long time to process process data with LLMs. Whether you're using GPT or Llama 2 or whatever, if you can find a way to use smaller models and decompose your problem into simpler instructions, those smaller models are going to run much faster. And so that's partially why we have this mix of models for you all to try. Is part of the problem that people are facing in industry is like, oh, I want to process these million documents with a large language model. For one, on a closed API, you're going to go bankrupt if you try to do that because of the token usage. But for two, it's going to take a long time with a really large model or a really large open model. So the more you can decompose and simplify your prompts and use smaller models, but maybe more calls, that may be more efficient than using larger models with obvious trade-offs. So those are a couple of the things I wanted to mention. We'll look for you in Slack. Let's see. If there are 5 symptoms, what should be the output structure? A comma separated list or some other format? Yeah, so thank you. So there could be multiple symptoms mentioned, and the output structure that we would be expecting would be what a human transcriber would respond and put in as that. So it should be natural text that describes the symptom. That may be a comma separated list, or it might be like if it's just one thing, just that word, or if it's 2 things like this and that. But if it's many things, it's how you as a human would describe it. So this, comma, that, and that. Other questions? All right. No other questions. Hopefully you're having some amount of enjoyment working on this. If you, like I say, if you are getting frustrated with certain things, please reach out to, and it's, we won't be able to solve certain things for you. But if you're getting frustrated with specifically like coding or API related things, we can solve those at least. So please reach out to us within the Slack channel, and we'll do our best to make sure that we can help you through those issues. Okay, thanks all.